Can they see it all right? Yeah.
Can you move the laptop a bit to the side, maybe?
Am I blocking the view?
Yeah.
Okay.
Nice.
Intersection of lines is skew lines. We know from last year that there are 3 situations that can happen when you have 2 dimensions and you have straight lines. They can coincide, be on top of each other. They can be parallel and distinct, or they can intersect at one point. When we have 3 dimensions, then we have slightly different situations. There are 4 possibilities when we have 3 dimensions. The lines may coincide, be absolutely on top of each other in all aspects. They might be parallel and distinct. They might intersect at a point, or they might be skewed. So there are 4 situations. If they coincide, then they're same gradient, and there is a point that's common to both of them. So in space, they are 2 lines that are identically on top of each other. If they're parallel and distinct, they could be parallel lines in space, and they never intersect. Parallel lines in space, remember we're IJs and Ks. They may intersect at a point, so they're parallel, and at some point they will intersect at one point. Or they might be skewed. They're not parallel, and they never intersect. Not parallel, and they don't intersect. Most lines would be not parallel and not intersect. So there are 4 conditions. For skew, they do not intersect and they're not parallel. That's what the skewed lines are. If they coincide, we can determine whether 2 lines in 3 dimensions are coincident or parallel by similar methods as in 2 dimensions. If they are parallel to each other. If they're parallel to each other, then this D component of each of them will be parallel, because that's the direction that the line is going. Intersecting lines, if for some proportion lambda or mu, they are equal to each other at some point, then they'll have an intersection. And concurrence is the point where they all meet. If there's 3 or more lines, we call it a concurrence. And angles between 2 lines. We can use the dot product that we had in chapter 4 to help us work out the angle between 2 vectors. That from chapter 4, we said that A dot B equals the magnitude of A times the magnitude of B times the cos of the angle between them. Rearranging that, you end up with cos of theta equals A dot B over the magnitude of A over the magnitude of B. So it's D1 dot D2. That's the dot product of vectors. When you do the dot product, you get a number answer. Over the magnitude of 1 over magnitude, we can use that to work out the angle between vectors in 3-dimensional space. The angle between 2 lines is between 0 or 180, because if you get a cosine that is a negative answer, you might get 130. If they're asking for the acute angle, you just do 180 minus that answer. Now, this applies to any pairs of lines, whether parallel, intersecting, or skewed. I would think parallel lines, if they're parallel, the angle between them is 0. Even in 3-dimensional space, if they're parallel lines, the angle between them would be 0. Perpendicular lines only if D1 dot D2 is equal to 0. Is that okay so far?
Yeah.
Okay,